Okay, so I gave you guys this table in the lab this week that you're going to fill in. And I just wanted to make sure you kind of knew how to use it. So I'm just going to go to sheets.new. We're going to get a new table here. And I'm just going to go ahead and press Control C and copy this, and press Control V and copy it over here. So let's talk about what some of these things mean. These are data that you should have recorded, your raw data. Here is our first calculation, which is our weight change. And the weight change is equal to the final mass minus the initial. So you could easily do this in your head, but I'm going to do it the lazy guy way, and I'm going to hit equals G4 minus F4. Because I want this final mass number here minus our initial mass. And that's telling me that this particular piece of potato lost 0.4 grams. By the way, do not use these numbers. They are bogus. I'll know that you cheated if you do use them. This is just so that you learn how to work the numbers out. So now that I have my formula written and I'm fairly confident that it is correct, I'm going to click to highlight this cell. Don't double click. Just single click to highlight the cell, or you can use the cursor keys to get over so that it is highlighted. Okay, we've got our formula written. We're pretty sure it's right. We've got our cell now highlighted. So now that it's highlighted, I'm going to click on it one time. Oh, I'm sorry, it's already highlighted. So now I'm going to go and take my cursor to the bottom right-hand corner. We're going to go to the bottom right-hand corner, and you see how the cursor turned into this black X? Kind of need to be precise. You need to go right over the corner, but you want your cursor to turn into this black X, and you're just going to click and drag down, and the formulas are going to come with it. Okay, G5 minus F5, that's what we want. G6 minus F6, that's what we want. G7 minus F7, that's what we want. So Sheets in Excel is smart sometimes, and it can do some stuff to make your life just a little bit easier. Now let's talk about the percent change. The percent change is the weight change divided by the initial mass. I guess this should actually be mass change. So we want the mass change divided by the initial mass. And the way we write that in Sheets or Excel or whatever is the H4 in this case, or wherever your datum happens to be, and then slash, which indicates divided by F4. Okay, and that tells us 0.2. And actually, we aren't quite there yet. We might as well do this correctly. So I'm gonna just do the same thing. Equals open parentheses H4 divided by F4. Now I'm gonna close the parentheses and put an asterisk 100. Okay. So what this tells us is this particular piece of potato lost 20% of its mass while sitting in this pure water concentration. Okay. This is not correct, by the way. This is not what you should be seeing. These are just numbers so that you learn how to use the sheet. Okay, so now that we have that written and we're fairly certain that it is correct, you are going to click this cell just one time, and you're going to make the cursor turn into a black cross by moving it into the bottom right-hand corner. You're going to click and drag, and this will give you your percent changes for the rest of your values here. Okay, so the first potato slice lost 20% of its weight or mass. The second one lost 0. The third one gained 40%. The fourth one lost 50%. And so we need to figure out the tonicity here, but the tonicity of what exactly? Let's go back to the sheet here. This means the tonicity of the solution relative to the potato. I'll paste that there so that we don't forget what this. So let's think about tonicity, or the tonicity of the solution. So remember, wherever solute goes, water is sure to follow, right? And so water is going to go toward wherever there is more salt dissolved. And so in this case, in this top one, where is there more salt? Well, according to this, it's in the solution, right? It's not in the potato. Water is leaving the potato for the solution because there's a bunch of water dissolved in the solution. And so this is what we refer to as a hypertonic solution. Think about it like this. When kids are hyper, they have too much energy, right? They have too much. They're sort of extra. There's extra solute there. There's extra energy there. This is a hypertonic solution. And you also need to be careful because this is a hypotonic cell. Remember, this is relative terminology. Okay, so like this pen is above my desk, but my desk is also below the pen. The solution in this case is hypertonic, but the cell is hypotonic. Okay, so this next one didn't gain or lose any weight, and so the solution is isotonic to the cell. Iso means the same. Water's not going anywhere in this case, and so it is isotonic. It's already at equilibrium. This cell down here gained a bunch of weight. Okay, so where is water going? Before we even think about tonicity, let's establish where is the water going. It's going into the cell, right? The reason that the cell gained a whole bunch of weight is because water came in. Okay, so where is the solute? Well, the solute is inside of the cell in this case, right? That's why all the water went into it. And so now I would say that this solution is hypotonic relative to the cell. Think about hypothermia. Think about hypothermia. You don't have a lot of heat when you are hypothermic, right? So in this case, the solution is hypotonic. It doesn't have a lot of solute, and so water is going to go into the cell. Let's look at the last one here. This one lost approximately or exactly 50% of its mass. Why? Why did it lose weight here? You take a potato, you put it into some water. The water is going to go wherever there is more dissolved solute, right? Water is going to go wherever there is more dissolved solute. And in this case, it left the potato. How do you know it left the potato? The potato got lighter. Okay, so there is more solute in the water, in the solution in this case. So I would call this a hypertonic solution. Okay, and again, don't use these numbers. This is bogus. When you really start to think about it, this chart can't really make any sense. But I just wanted to make sure you guys understood how you can construct one of these pretty easily and figure out what the tonicity of the solution is relative to the cell. And by the way, this would mean that the concentration of this potato is about 0.031 grams per mil.